Let me know when it starts. All right. Has the recording started?
Yes, it has.
Okay, thank you. All right, we're going to be talking about evaluating project progress tonight. We've got a number of slides to get through, so uh, keep somebody keep me honest on time. Don't let me take more than about 3 minutes per slide. All right, I put the title of John Doerr's book in the chat. It's actually Measure What Matters. So what uh, you can take, there are a lot of parameters that you can measure. What you want to be able to do, and Doerr's book was one of the first ones that documented OKRs, which are objectives and key results. You want to have uh, uh, yeah, uh, measurements on things that you can control. Your metrics need to be only things that you have an effect on. Okay, so don't try and measure entire um, like the entire process for developing something if you've got a handoff from somebody else and you're handing off to somebody. Okay, make sure that your measurements only uh, are for what you do. Okay? Uh, for budget, I mean, if you're tracking actual costs, uh, if you're an adaptive project, realize that your costs may vary based on customer feedback as to what they need at the point of time uh, when you're doing the development for them. Okay, they may have changed their mind about something, may have needed to add something, to take something away, so that when you have an original budget for the project, it may need to change. Realize that, make sure that everybody's in the loop on that. Okay. So there are some ideas here of where you can measure progress. All right. Some reports that you can create and definitely tailor them for your specific project. Right. These are for adaptive and hybrid. Some milestone schedules um, to give uh, stakeholders an idea and also the team an idea of where there are major milestones that they need to hit. For example, if you're creating an all new, a brand new product, and one of the milestones will probably be delivery of MVP or minimum viable product to your customers and getting their feedbacks. Uh, Quality reports, and remember, measure what matters. We're going to be talking about earned value management in a little bit. And that's the mysterious graph that I put in the chat. Uh, Variance analysis reports, we're taking a look at what was predicted versus what real life is at that point in time. Okay. Work performance reports. A lot of times they'll use like burn up or burn down charts. We have to be careful of those, especially in an adaptive project. And then naturally dashboards. Uh, just a nice way of presenting a lot of data to your stakeholders so that they can slice it and dice it however they want. Okay. All right, monitoring scope. Now, has anyone ever experienced scope creep?
Absolutely.
Yes.
All right. All right. I'm glad to see that all AT&T is about the same. All right. So if you have a predictive project, you have a scope baseline. Okay, you've developed everything based on that baseline scope. Okay, your work breakdown structure, your WBS dictionary, your budgets, uh, your staff loading, everything like that. So um, what you want to continuously do at regular intervals is measure completion of scope against the scope baseline. Okay, if you're 10 weeks into the project, you should have a certain amount of the scope that's been completed. So you need to monitor that, report that, and if you have any deviations from that that you can't handle, be sure to get help with that. Okay. With adaptives, purely adaptive, you start out with a general idea. Okay. You put together an initial product roadmap, and the scope evolves over time. And the way to track that is uh, with the various iterations of various releases. Remember that there's a difference between iterations and releases. Releases may encompass more than one iteration's worth of work. Okay. So check those against um, your progress and your budgets against what what uh, your wet-fingered guesses at the beginning of the project were. Okay? Especially if you've got a fixed budget for this uh, project, rather than but what we were trying to do at AT&T, at least in the leg organization, was fund based on the number of people on in a developers and teams for an extended period of time, say a year, so that we're not uh, worried about exactly what's being delivered. Okay, we realize that there can be changes based on customer needs, customer desires. Okay. everything naturally has to be put in the backlog. All right, for product backlog and for iteration backlogs. And hybrids, you know, you can combine, you know, anything of the two. All right. Scope validation. All right. Here's a couple of questions to answer. The predictive development approach, which artifact helps determine the acceptance criteria? A 1 in 4 chance on it.
Team charter.
Uh,
Yeah.
Team charter.
Yeah. Our scope
I
statement.
think it's a scope statement. Yeah, I think it's the scope statement.
Okay. And in an adaptive development approach, what helps determine the acceptance criteria for user stories that has been met?
Definition of done.
I'll take that. Okay. So predictive, you're really looking at the acceptance criteria that you've laid out during your project planning. With an adaptive project, you establish the definition of ready, meaning something is ready to be worked on, and then a definition of done, which gives you an indication of what remains. How to evaluate whether or not a story is completed. Okay. Your product owner is going to develop acceptance criteria. Okay. This is how this is uh, what things are supposed to be doing. A definition of done is usually set up by the team themselves so that they determine, um, they define what has to be done in order to move an effort into a done state. So it can be that, I mean, it's usually basic things like acceptance criteria met, uh, the code for the story has been moved to a completed state, things like that. And it can vary from team to team. And for each iteration, remember we've got we set aside a block of time for an iteration review to talk about how things went, you know, what was accomplished, what wasn't accomplished. Okay. So, and then once everything is, you know, completed internally, at the very end, the customer is really, the final acceptance, because it doesn't matter what we do internally, it's the people or the organization that pays the bills that determines whether or not we've done the job right. Okay, we want to measure schedule performance. One of the tried and true methods over actually decades that started in the last millennium, Gantt charts, which show progress. Okay. For all predictive, hybrid, and adaptive, we have things like earned value, determining how much value we've produced based on what our predictions were. Okay. We have quality metrics. Uh, it depends on what kind of a project you have. If it's a manufacturing project, uh, you know, metrics can include things like line stoppages, amount of rework on physical components, things like that. With software, it can be the number of defects uh, that have escaped, number of defects that uh, uh, made it through to the next phase from when they were introduced. So, uh, one quick question for you: what are the most expensive defects to fix?
The ones that have been produced in the customer's hands.
Production defects.
Well, the defects that are the most costly are the ones that get to the customer, because they need to be traced back to where they were introduced, root cause analysis done, and they need to be fixed uh, and redelivered to the customer. So you've got a lot of development tests, especially with predictive projects. Okay? So the cheapest defects to fix are the ones where you identify it as a defect in the same phase it's been introduced in. Okay, if it's a coding defect for software development, if you can keep it within the same iteration, understanding what where it was introduced and fix those defects, that's the cheapest ones. Okay, the ones that escape to the customers are always the costliest ones. And it's not only the amount of money that it takes to rework things, it's also the organization's reputation with the customer. Okay, so you don't want to deliver defective things, products to your customer. But there are times where it could be a good thing, uh, delivering a defect to the customer. I was involved in a project at a different company where we were upgrading general processor boards and had a strict timeline we had to meet. So we put all the boards together. We, verified that they ran the code and everything. And we shipped, the first batch of boards to the customers um, for them to do verification in their labs. And first board they plugged in caught fire, literally caught fire. Flames came out and everything. Well, it was either going to end up terrifically, or as it turned out, it ended up well because we were able to isolate the issue. We're able to demonstrate to the customer that if something did happen, we had the ability to do the root cause analysis, make the corrections in the process of developing of producing the boards, and you know, it was done in a very, very short period of time. It was like a week and a half for the whole process. So, and naturally, it was a capacitor that blew up. You know, for anybody who's worked with electronics. So, keeping track of quality metrics is essential. Variation analysis takes a look at what's being produced and uh, seeing how many products are delivered that work within tolerance or outside of tolerance. And if you're doing variance analysis, you have an opportunity to uh, do root cause analysis on any of the issues that could cause that variance, okay, and correct that before, hopefully before anything shipped to the customer. Okay. All right. For adaptive and hybrid projects, uh, we have a smaller interval that we're dealing with, say an iteration. Okay, so we're going to be estimating how much we can deliver each iteration, and that's a term. The term for that is velocity. So you're going to see that later too. All right. So we're going to be constantly comparing our estimates to our actuals. So we've done each iteration. Each iteration, what happens in an adaptive project?
You decide on what user stories to produce during that sprint.
Say again, please. Sorry, I'm having trouble hearing.
You decide what user story you're going to do during that sprint.
Okay. That's true. In general, for every iteration, what do you deliver?
You know, deliver like a certain piece of the project during that iteration. So then you can actually have you need to have someone like approve, not necessarily approve it, but to see, okay, are you on the right track? Do they like it? Do they want to make some slight changes? You can go back and change those for the next iteration that you do.
Okay. What about at a higher level than that? What should every iteration achieve?
Some sort of value for the customer.
Exactly. You deliver value. Okay, that's the key concept to remember for iterations or for sprints. Okay. So what you're going to do is you're going to review the completed work during the demos, and you're going to determine what value was delivered. Okay. And naturally, we're going to be using retrospectives multiple times through the development cycle. Yeah. You can conduct scheduled reviews to record retrospective discoveries. You really need to be doing that every retrospective. Okay, you need to identify what, uh, you know, any of the defects, any things that went well for each of the retrospectives, and then incorporate that into your development process for the next iteration. Here are the definitions. I'll give you a few seconds here and take some time too. Okay. All right. Schedule management tools, especially for predictive projects. Okay. Now, you may have some changes uh, in the number of resources that you have available. You may run into something, say in a construction project, where you need a crane. You can't get one in the area. You know, they're either all being used or broken down. Okay, so you're going to have to adjust your schedule. If you need additional software developers, it's going to take some time to get them up to speed and everything. So that's another reason to adjust your schedule. Now, we talked about some concepts a way back called smoothing and leveling, where resources are allocated in areas of a predictive project where they are needed more than what they're working on at the current time. So you need to keep your eye on progress for the projects and where some time can be improved or delays avoided. Now, we also talked about fast tracking and crashing. You got to be real careful if you're using this. Okay. You're pulling resources. You're with crashing. You're throwing people on the project, right? With software, um, now one of the great resources, great fundamental books for software development is called The Mythical Man Month by Fred Brooks. He was in charge of developing IBM, uh, their OS 360. It was way back in the 60s. And his conclusion is that if you throw additional people on a software project, it's just going to make it later. So be sure that you've got a good reason to do crashing, that you monitor it closely. Okay? And then fast tracking is starting things before uh, the preceding task is completed. And you can do that at times. It, again, you need to be cautious about doing anything on this second line, this bottom line here. Okay. All right. Talking adaptive, we're talking hybrid. Um, we're going to assume that you're going to be doing a team dashboard. And a lot of the tracking tools will aid you in putting together a dashboard. And there've been a lot of tools that have come on the market that really make developing dashboards pretty easy. Uh, you can use burn down or burn up charts. It is, you have to be wary about that. They can give you a false sense of a false positive. Okay? It depends on, you know, exactly what's left. Okay? Have you been doing just very easy work? Okay? And then have saved a lot of the hard work for the later phases of that particular sprint. You know, so use them. Make sure you understand what the true state of the development effort is. If you're using burn down, burn up charts. Uh, we use, we talked about information radiators, whether it's you know, written on on a, on a poster board, whether it's electronic. You want to make sure that everybody associated with the project understands where it's at. We're going to talk about these in a little bit, cumulative flow diagrams. And what they are is you take a look at the incoming work, the work that's in progress, and the completed work over a period of time. As I said, we're going to see a lot more of that tonight. Okay. Agile approaches usually use Kanban boards. Okay. And these help illustrate the state of the project. Okay. Now we'll talk about velocity too. And this is the number of story points that a team can deliver in a single iteration. Yeah. If we have a continuous flow approach, especially in a manufacturing process, we can show what the throughput is, the cycle time, and the lead time. I also do this for software, and we're going to see that when we do a cumulative flow diagram. And all right, we talked about velocity. We should have, yeah, we've got a little video here for information radiators. Please let me know if you can hear this.
90% of all the information
Yes.
transmitted to the brain is
Thank you.
visual. Not surprisingly, visuals are processed 60,000 times faster than text. We are wired to automatically interpret patterns for instant comprehension with almost zero effort. Want to see some examples? What do you see right away? A different shape. And with this one, a different size. And with this one, a different color. That brings us to an information radiator. An information radiator is a type of visual control that displays project information in a place where passersby can see it and get information without having to ask questions. The far left column of this example starts with the project charter. This lists the project's primary objectives, key features, and cautions and risks. It also lists those who have key roles in the project's completion: the product owner, the architecture owners, and the team lead. Finally, it provides a glossary of project terms which may not be widely known. The next column of this example indicates any impediments and blockers that are slowing or preventing progress on the project. This includes both known and outstanding blockers, and those that have been mitigated or completed. The bottom of this column provides a convenient place for the color coding to reside. In this case, green for done, blue for started, red for blockers, and yellow for dependencies. The large center section of this example shows the product backlog. It also shows the iteration backlog, the specific tasks being worked on by members of the team in the current iteration. The far right section of this example shows the iteration burn down, the rate at which the team is burning through its customer stories. This can tell the team whether they are on track, ahead, or behind the committed work. It also shows the release burn up. This monitors progress of release commitment iteration by iteration and gives the team a projection of when they will meet their release goal. And finally, it shows working agreements. These agreements detail how the team will work together and what they can expect of each other. Of course, this is just an example. Your information radiator should be customized to meet the needs of your team.
And remember, if you have uh, people who are not co-located, what you need is an information radiator that can be accessed by everyone on the team and all the stakeholders. Okay. Putting a piece of paper up in an office or a conference room in one location is counterproductive. You need to make sure, however you display the information, that it is equal for everyone. Okay. This, this is a burn down chart, and the blue line is predicted. Anything that's straight diagonal is your projection, because you're going to be burning down from about 190 story points down to 0 over this iteration. Okay, because how much time do we have here? This is a little bit under 3 weeks. Okay. Then what you do is you measure or you chart your actual completion. Right. Now, story points for these. If you've got, you know, the old expression, garbage in, garbage out. So if your estimates are wrong, your results may be less than what the predictions have been. As in this case, okay, we estimated that we're going to be down to about 125 story points, and we've actually burnt down past 100. Okay, so and this is an idea. Excuse me. Kind of an ideal curve. for the actual burn down, because you end up completing before uh, before you predicted. Okay, and you've got a large number of story points that you're burning down. Okay. You'll generally you'll see above, below the line. But you know, this team was doing a pretty darn good job of burning it down. You know, you want to take a look at, you know, whether or not the your estimates the next time are more accurate going into it. Okay. Burn up charts. We're talking about number of story points that are completed. The blue line is the projections. And if you take a look here, middle of iteration 5, an additional story points worth of effort was introduced. And you, okay. So that at the end, we've got, you know, the additional 20 story points. If the teams, okay, all right, have, yeah, if they're meeting their velocity and have done their estimates as to what they could accomplish before the introduction of additional story points, this is what you're going to get. Um, their estimates were pretty accurate. They delivered almost what they originally committed to. And they were unable to meet the additional work that was that they were saddled with. And the you know, if they tried to introduce additional developers here, uh, remember what I said Fred Brooks came up with? You add developers to a late software project, what happens? All right. Add people to a software project in order to try and compress the time. You're going to make it
Worse.
worse. Absolutely. Okay. But this is what a burn up chart looks like. You're going to do it over a longer period of time. All right. This is what they call a task board. This is really as basic a Kanban as you can have. You have a list of items to do. You have the work in progress, and then you have the whatever items were done. Okay. So they say the task board types include Kanban, to-do lists, procedure checklists, and Scrum boards. Okay. They all degenerate, I believe, into at the very worst, a very basic Kanban showing the 3 states. All right. Teams will estimate the amount of work they can do each iteration. Again, that's the velocity. Okay. Different teams can come up with different estimates of how much they can do when given the same amount of work. Okay. It depends on the expertise. It depends on the knowledge base of the team and their experience if they've ever developed something similar. Okay. So team A may say that they can do 30 story points per iteration. Okay. Given the same work, team B, they say, oh, we can do 50 points. You know, we've done our estimates, you know, based on our specific knowledge, our specific, you know, experience. We can do the 50 story points. Okay. What you want to do is do your initial estimates. And when you're first putting together a team, the estimates are probably going to be wrong. Don't worry about that. You learn from that. Okay. Subsequent iterations, you ask more questions, the team asks more questions. Determines, you know, how many story points they feel that they can do. And, you know, that's the velocity that they expect for the next iteration. That may be wrong too. What you want to, you want to keep the variation from iteration to iteration as small as possible, whether it's below the line or above the line. Best thing to do is hit the line exactly. Second best thing to do is end up a little bit or even a lot above the line, the estimate line. But you really want to have the same velocity, the same amount of work done each iteration. Okay. Now, if the work changes from iteration to iteration, and say that the new work allows a team to use more of their expertise, then you may have a variance in your velocity, like at this point here. Okay? Because based on what the team can do, they may be able to deliver more value within an iteration. One of the big goals is to get this as tight as you can to the estimates. Make sure that the estimates and the actual deliveries are as close as possible. Velocity is a unique metric to a project, okay, because you're not going to have the same composition of individuals for each project that you deliver. And as I said before, velocity can vary from team to team when when they're delivering the same work. Right? It's a team specific measure. And you can't compare any two teams with each other. Doesn't work. Here's the fun time. Continuous flow diagram. Okay, you can measure what we have here is the dark brown here is what's queued up to work on for this particular period of time. The blue is what's in progress, things that have started but not yet completed. Okay. And the purple curve here is the accomplishments, things that were done. Okay. Now, lead time is a measurement of when an item enters the backlog until it's completed. Okay. You may need to know these definitions. Cycle time is a measurement of how long it takes to develop a story. And so once it's pulled from the backlog, how long does it take to deliver that that functionality, that value, okay, where it's done? Work in progress is measured. It's just a measurement of the blue curve at any point in time. Yeah. And then the backlog at any point here is the width of the curves. Okay. Any questions about this? All right. Jeez. All right. Okay. Things that can affect your budget are a change in requirements. If you identify new risks, and this is especially in a predictive project because you've done all the risk planning up front. Or if you discover that a risk is more likely to happen or that it could have a greater impact on the project. If there's some reason for cost estimates to need to change, such as if you're building something that requires materials, if there's a an increase in the cost of obtaining those materials. All right, we're going to talk about earned value management. And this is so much fun. What you're going to do is you're going to measure your actual project progress against what the estimates have been. You're going to take a look at both schedule and budget. And by doing this on a regular basis, you shorten the feedback loop so that you can uh, address any of the budget or schedule issues early on. Okay. A lot of stuff here. Plan value is the orange line. What we call earned value is the yellow line. And the blue line is actual cost. Right? I put a little graphic in the chat early on. Okay. Make sure you uh, copy that or look up earned value management in, you can go to like Wikipedia to take a look at it. Yeah. Because what we're showing here is that we were ahead of schedule and we were uh, actually spending more money than we thought we were going to be up until these points here. So let's take a look at what we have here. So I don't believe you're going to have to do any of these calculations. What you will need to be aware of is if you have a value here that is less than 0, that it indicates that the project is behind schedule. If it's greater than 0, the project is ahead of schedule. So uh, so here we're ahead of schedule because it's greater than 0. It's earned value minus plan value up to this point where it crosses over. So we need to, in this case, we need to investigate why we've crossed over and our earned value is less than our planned value. Okay. One thing that you take a look at is the schedule performance index. And it is a measure of efficiency. So in this calculation, you divide the earned value by the planned value. Okay. So that if you've earned more than you've planned for, in this case, your schedule schedule performance index is going to be greater than 1. Right? So your project is ahead of schedule. If it's less than 1, you you got to get that earned value up so you can cross cross the line there. All right. Can also use it for budget purposes. Cost variance is the earned value minus the actual cost. Okay. If the cost variance is less than 0, you're below budget. If it's above 0, project's over budget. Okay. There's also something called cost performance index. Know the terms, know what it means to be what your values are measured against. Because here it's against 0, here it's against 1. So know that what you're measuring against. Okay. And in here, anytime you're doing a subtraction, you're measuring against 0. Anytime you're doing division, it's measuring against 1. Okay. So your cost performance index is your earned value divided by the actual cost. Okay. So let's take a look at a couple of pages back. Earned value divided by actual cost. Okay. So your earned value divided by your actual cost, okay, is going to be what for these points?
It'd be below budget if it's less than 1, and it'd be over budget if it's above 1.
Okay, what would it be here? They may just give you this, not have, any, not even this amount of data on there. Okay. So what do? We divide earned value by actual cost, right? Because we've earned this much and it's cost us this much. So as long as the actual cost is above the earned value, it's going to be less than 1. Your cost performance index is going to be less than 1. Okay. I think I lied to you. No, I didn't lie to you. Because we've earned, say, 150,000 here, and we've spent, say, 175,000. Okay? You don't have to have actual numbers on these lines. You can do the analysis, and you'll probably be asked to do the analysis without all the data. Knowing what the uh, the relationship is, as to the where the lines are. Okay. So with this, we can say that for the entire project so far, the cost performance index is what? It's always less than 1. We've got budget problems. Okay, we're spending more money than the value that we're returning. Okay, so you got plan value here, and your earned value is above your planned value. You've delivered more than you planned for. Okay. If you see it crossing here, okay, that means that you're delivering exactly what you earned exactly what you planned for. If it crosses like this, it means that we've got a problem occurring because our earned value is less than we predicted. So you can tell a lot from these graphs just by how the lines themselves fall. Okay, so we've got budget problems throughout the whole thing, and after this point, we've got schedule problems too. Work on these with your mentors. Ah. Two things that we take a look at. What the projection of what the total project cost is going to be at completion. Now, uh, remember, especially in a predictive project, we had a budgeted completion. Okay? That was our estimate. Okay. Based on the uh, the information throughout the project at that point, you can estimate what uh, what is going to be at completion by taking a look at the current spending efficiency and dividing the budget of completion by that current spending efficiency. So if uh, our current spending efficiency is less than 1, we're going to need more budget. If our current spending efficiency is greater than 1, we're okay with the estimate at completion. We should be able to be within budget. At least that's the trend so far in the project. So this is why you need to monitor this throughout the life of the project, because it's going to it can change. Okay. And then yeah.
I had a quick question. So is it frowned upon if you are under budget by too much or over budget? I know it's frowned upon if you over budget by too much, but is it frowned upon if you're under budget by too much?
Well, that's how I got a job at AT&T, was being pretty far under. Um, when I was a contractor at AT&T, I had a project to change out a PBX in Rosemont, Illinois, for AT&T long distance, and I was given the project, I was given the budget estimates and everything, and I was able to deliver the project at about $500,000 under budget. So um, it depends on your organization.
You
If
give
you-
yourself a nice bonus being a project manager.
No bonus. I was a contractor. Can't give contractors anything. So, no, but I got a job offer out of the deal, which paid off. So I was able to work at AT&T for over 17 years. Um, it, it, it's going to depend a lot on how your financial team works with your development team. Because if how can I express this? If you deliver something extremely under budget, they could affect the budget for the following year. Okay, if you're working with your finance team pretty well, you'll ideally be able to use that that additional budget for projects that weren't possible to address. Okay, in that current year. So it depends on the funding model. It depends on how well you get the development and finance work together. So sometimes it's good, sometimes it can be bad. If you've got to spend budget in order to get budget next year, you know, that's always been the big trade-off that it's kind of difficult to really understand. So anyway, I've rambled enough on that. All right. The other formula here is estimate to complete. Right? This is the amount of funding and time that you're actually the funding is going to take to complete the project. And it really is just the estimate of completion, which we did up front, minus the actual cost. Yeah. So if we have if we're spending more money than we anticipated, the estimate to completion is going to be higher. If we're spending less than we anticipated, okay, then our estimate to complete is going to be lower than we estimated. And again, this is just information. This is just data at a particular point in time. It's not an absolute measure. It's not something that you can absolutely use. These measurements are there to raise flags, okay, to make sure that you as a project manager fully understand the reasoning behind any changes from what you estimated originally to what the actual delivery is and the actual cost. Okay. All right. These are indicators. And it really is incumbent upon you, the project manager, to interpret this data, to understand the context of the data. and to make the appropriate decisions. Earned value management. Okay. Definition enables comparison of release plan against the actual work done. Right? It helps teams spot any problem areas and ensure they stay on schedule and within budget, or you know, indicate where they're deviating from that. Example process here: establish a baseline, answer 3 questions. How many iterations are planned? How many story points are there? What is the release budget? And yeah, your release budget can include both human resources and non-human resources too. Okay. At the end of every iteration, collect these 3 data points: plan value, earned value, and the actual cost. And again, that goes back to that original graph. This is for any point in time. Okay. Just give me a second here. Okay. Let's talk about where the project manager needs to lead resources, manage and lead resources. Now, you've got to include both the internal team and external contractors. And one of the big caveats on the external contractors is right here. You have to understand what the contract terms are and what the conditions are for working with the supplier or contractor. Okay, I know at AT&T, I was working on software development, and then I'm coaching some of those efforts. There was a mixture of direct employees and contractors. An AT&T employee cannot directly direct a contractor. You have to go through the contracting company. Okay, there are certain points of interface that you have to go through. That may not be, it may be different in other companies, but at least within AT&T, you can't tell a contractor what to do. Can't tell them to work overtime. Can't tell them, to start at specific times and end at specific times. No. If you need to modify a schedule, you have to go through the contracting company's representative. Okay, negotiate things that way. And really what monitoring for risks, okay, some of the risks being like cost overrun, schedule delays, potential disputes. And we talked a lot about cost overruns, schedule delays in the last section. Stuff happens. Okay. Depending on who you're using on the project, if you've got people who are non-management within AT&T and negotiated uh, or negotiated group, or if your contractors are, uh, you definitely want to be aware of any potential disputes between team members. Okay. 4 things to make sure you check on contracts if you have them. You definitely have to have compliance to your procurement process. You can't go out and just engage someone to do work. You should be getting feedback, accomplishments from them on a regular basis. Suppliers, if there's any change in what you originally contracted for, need to make sure that they get advance notification and that you're notifying your stakeholders at the same time, or actually before. Remember we talked about in contracts a few weeks ago about some contracts may be payable on completion of specific work. Other ones could run the entire length of the project. Okay, so if you have contracted deliverables, if you're buying software, if you're buying, say, yards and yards of concrete from a vendor, make sure that you go through the formal acceptance process that you've documented in the contract. Okay. That's why it's very beneficial to have experienced people uh, negotiating the contracts, right? And we want to pay on time based on what the contract calls for. All right, physical resource management, we're talking about equipment, materials, facilities, infrastructure. Okay. What you want to be able to do is get any physical resource that you need just in time, and just before you need to use it. Now you may have lead times in there. If you need some large electronics lab that needs to be set up, that just in time may take a number of months to get everything set for when your development team needs it, or your or people who are doing tests need it. Okay. Other times, if you're building a building, you need a large crane. You just want to make sure you get it there, maybe with sufficient time to build the crane on site and to be ready to do the heavy lifting there. Okay. And you need to determine when you can release that equipment, right? So that your total cost is minimized for these physical resources, right? And naturally, you're going to need to make sure that what you planned on and what reality is pretty darn close. Because by making sure that uh, resources are available as you planned them, okay, nothing strange has happened. Uh, you know, Bob the Builder hasn't uh, over overpaid to get the same resource that you absolutely need. So you thought Bob the Builder was a nice guy. Uh, you want to make sure that you keep track of how much you use the resource and compare that to your plan to help the next project, especially uh, this, the next similar project, to do a better, more accurate, let's say more accurate budget or plan. Okay. All right. Let's take a look. Oh my gosh. All right. We got to kick this into higher gear. Okay. For predictive updating resource allocation, now take a look at what the state is uh, today and compare it to what you planned on. Okay. Make the appropriate changes. Okay. That's really what we're talking about on this slide. Now, you may not be an appropriate person to handle contract changes and disputes in the real world, but this is what PMI is going to be testing on. Okay. For predictive, you're going to perform integrated change control, and for adaptive, you're going to take a look at what effect it has on the backlog. Okay. So if you have contract disputes, you should have an organizational process asset that addresses contract disputes. And that's your first place to take a look. Then get the right people involved. Quality management guidelines. They're going to assess the quality of project approaches and activities, evaluate deliverable quality through inspecting and testing. All right. So remember we talked about all those different ways to assess quality. You need to be doing that. Focus needs to be on detecting and preventing errors and defects. Do things like root cause analysis, and that. We're going to take a look at that in a minute here. All right. Predictive projects. You've got the control quality process. Okay. You're going to use that as your main guide. For adaptive projects, you're just trying to get through a whole one. All right. The product owner needs to be working with the customer on the quality aspects of the product. And what you want to be looking at each iteration, especially if you're delivering a product for the first time, that you're uh, you're looking at the quality aspects and monitoring them throughout the life of the project. uh, KPIs, key process indicators. Uh, yeah. If you have anything written in the contract on what to measure as far as quality is concerned, yeah. And use your resources. All right, predictive quality audits. Uh, they can be ad hoc. They can be scheduled. Any way that will work. Now, your audits need to be based on what what you want to achieve. Yeah. All right. So you want a baseline with it, and you also want to see any deviations in quality. We'll talk about a few things later here too. We've got definition of a quality audit. Really straightforward. And the audit's only as good as your organizational project policies, processes, and procedures are. Okay. Remember, garbage in, garbage out. So you need to make sure that you're doing uh, that you're auditing against good quality process procedures. So some of your quality control tools, and this is true for especially hybrid and predictive, is your basic stuff. Gather the data, analyze the data, and then represent the data in various ways to help you understand what has been going on, where quality has not met expectations. Here's an example of a quality control process. Collect data using check sheets. If this is especially a manufacturing process, plot the data on a histogram, understand the significant ones using a Pareto chart, use cause and effect analysis on the chosen problems and solutions that are derived, and then uh, perform a scatter analysis to understand the correlation between the input and the output. This is a fishbone diagram or an Ishikawa diagram. These, depending on what your issues are, these may change. This is a good place to start. People, process, equipment, material, environment, and management. Okay. They say this is YY diagrams known as. Um, ones that I've used, we've gone to a 7Y process to determine what the root cause is. Okay. We don't necessarily stop at this level. Keep investigating. The head of the fish is what the problem is. Scattered diagrams. You can use scatter diagrams for any uh, two things. Now, in this case, it's process input and quality characteristics. Now, anywhere from 94% to 102%. So I think what we're looking at here is, uh, quality meets 94% to 102% of what was listed, agreed to. All right. In this case, process input, these should be the number of parallel things, parallel processes that that you're working. Okay, or serial. So if you have, if you've only got one thing that you're doing, this shows that your quality is high. If you're running 20, for some reason, this process uh, results in somewhere 6% defects. Okay. It's quality control chart. What you have, you've got max spec, min spec, and then we call it control limit, where if you go above that, your process is starting to get out of hand, and what you need to do is bring it back closer to the mean. Um, we can take a look here. This is a Pareto chart. And what it indicates, and really it does follow the 80-20 rule, that 80% of the problems are caused by 20% of what the defects are. So for a restaurant, feedback was overpriced small portions and noisy. Really, that amount, those complaints dwarf food not fresh or table not clean. And I may have some other ones out there too. Yeah. You need to understand what a histogram is. You need to remember the definition of the 80-20 rule. So make sure you've got these. All right. Okay. All right. With adaptive projects, quality is closely linked to the product acceptance criteria as described in the statement of work or other design documents. Depends on what your how much of an agile project you're really running. The design documents are really based on your user stories. Yeah. Right. So what we're saying is we need to examine that as part of each iteration and release. um, if we're running an adaptive project, we should have, quality goals set up. Should also have the tolerances set up. We need to verify that all our deliveries are within those parameters. And customers are really the final decision point as to whether or not the quality is sufficient. Now, we measure products and outputs against the project's quality standards. Again, it's only as good as what the project's quality standards are. Take a best guess, and it's incumbent upon a project manager to get feedback from the customer, whether it's directly from the customer or through the product owner, about what the quality standards need to be. Yeah. Know that PMI recommends an iteration H, or a hardening iteration, before you release something. There may be some other organizations that promote that, at scrum.org and a lot of the other frameworks that are in use today really frown upon an iteration H, because the quality should be part of each iteration. All right. So what we're saying here is, if your quality standards are out of range or if they're not being met, just understand why and make the appropriate changes. Now, we've been talking about risks since the very beginning. Adaptive development, you're going to be taking a look at risks every iteration. Things you've identified, any new ones, update the risk register if you have one, and also update the backlog. So the product owner needs to be aware of all these things. If a new risk is identified by the team, get the product manager involved, because it could have effects that you don't know, that the team doesn't know about, going forward. We'll skip the option. With just about like with everything with predictive risk management, it's very methodical. Okay. Some guidelines and questions to ask if you're monitoring risks in a predictive project. Uh, it's basically keep your finger on the pulse of the project and regularly assess uh, the risks that you've identified, determine if there are additional risks based on the current state of the project, and then address them. This is a list of questions to ask. Yeah. We'll be talking about risk audits in just a few minutes here. Um, for predictive projects, always review your reserves. Um, remember we talked about management reserves and project reserves before, two different buckets of cash uh, for each project to account for any budget variances that occur. It's not a one-time thing. You need to be doing it throughout the project. It doesn't have to be done every day. You know, you may want to do it like once a month, or depending on what the results were of the previous review, may require you to do it more often. Uh, so definition of reserve analysis, method used to evaluate the amount of risk on the project and the amount of schedule and budget reserve to determine whether the reserve is sufficient for the remaining risk. So again, we're using the best knowledge that we have at that point in time to make sure that we have enough left over at the end of the project. Okay. Agile teams can use a risk list or log similar to a risk register. You can also use a risk register. Right? If you've got something good that you can steal from other projects, use it. Okay. So you want to keep this, it's a living document. If you identify new risks, add them to the risk register. If risks have been mitigated or just no longer exist, remove them, you know, mark them as resolved. And again, you're going to be learning, hopefully you're going to be learning throughout the life of the project. So use your expertise, what you've learned. See if you know your initial estimates of risks need to be modified. We're going to try and finish up on time, so we're going to skip this. This is something that you can do in your mentoring sessions. We talked about compliance a few weeks ago, about complying with organizations such as the FCC, the FAA, and local, state, and federal government initiatives. So we need to make sure that manage compliance is the highest priority, because it won't do us any good to deliver a product that violates any of the compliance requirements that we have to fulfill. Okay. Examine business value. You know, when we start out a project, especially if it's over, it will take a number of years. Business conditions can change, and value may change as a result of that. Uh, it it may or may not require you to address, uh, examine the business value of the project often. Other projects, you're going to have to keep your fingers on the pulse almost continuously, especially if you've got some competition. We're also coming up with this unique uh, unique product. We did finish. All right. Questions? Comments?
Thank you, Harry.
You're more than
Thanks, Harry.
welcome. Whoever started the recording, can you please stop it?
Certainly.
It's
Done.
been great. It's been great